looking at G4, which is surface area. So before we can get really into solving surface area problems, we need to understand what surface area is and the difference between surface area and volume. Now, surface area would be very similar to the wrapping paper that comes on the outside of a present. Or maybe if you're painting a room, the ceiling, the floor, and the walls, that would be surface area because you're not filling it up. You're only doing the outside. Now, when it comes to surface area, what you're looking at is what we call nets. You're going to take a 3D shape and you're going to look at the net of it. A net is where you take a 3D shape and you fold it out flat and you see it as a 2D shape. So I need y'all to understand, though, that there are different ways that you can do this net and it would still give you a cube. You cannot put these sides beside each other because whenever they folded up, they would not meet. They would meet up, and then you would have some faces that would be completely open. So it has to be able to fold. So if this is the way we're going to fold it up, this folds up, and then these two fold up. Then you're left with this flat right here, which has got two squares on it, but this is going to flap that way and then come over the top, which makes our cube. So again, they can all be different, but what I wanted to point out to you guys was what makes the difference between surface area and volume. Volume is filling up a 3D shape. Surface area is lining a 3D shape. So again, you fill up a 3D shape with cubes, you line it with squares. So if I wanted to figure out the surface area, I would take all of my little squares and I would line my shape with squares. Now, if y'all wanted to figure out the volume, what I would do is to take these cubes and I would fill my shape up with cubes. So cubes fill up a shape. That's when we deal with volume. The lining of the 3D shape is surface area because I can take these squares and I can line this 3D shape, or I can also line my net of the cube because it's flat as a two-dimensional shape. So there's the cube. Now I want to look at the triangular prism. All right, so a triangular prism has two triangular bases that are congruent. They are the same. Now, again, just because we laid on this rectangle does not mean it's a rectangle. This is still a triangular base, okay? Because we can take this shape and turn it like this on the triangle, and we have a triangular base. The rectangles are just faces. There are three rectangular faces because we have two triangular bases. So the base is our triangle. If we were to fold it out and look at a net, we have three rectangular bases and faces, and then two triangular bases. So you would say 1/2 base times height times 2, base times height times 3. All right, so that's the net. And again, we could change this up. We could move this triangular base to this rectangle, and it would still fold and be exactly the same thing. All right, so now we're going to look at a pyramid. All right, so with a pyramid, you have one base, and then depending on what your base is, tells you how many triangles you're going to have. So since this is a square base, you're going to have 4 equal triangles because it's a square, okay? Because it's got 4 sides, 4 triangles, okay? Now, another one I want to look at is a triangular triangular pyramid. You have a base that's a triangle, and then you have 3 triangular faces because the base is a triangle. You have 3 sides. So here's how this looks. When I open this up, you have the one base that's a triangle here, and then you have 3 triangular faces. And so then it just folds up like this to where they meet at the top, okay? Let's see. Here's one more that is very neat. Might help us with pyramid understanding a little bit more. So we have a pentagon base, okay? We have 5 equal triangles here because it's a pentagon base. So when this folds up, we're going to fold this up to be the base, and then these are going to like fold around it and close in. So it comes up to this one point. That's why we call it a pyramid. We have 5 triangles, 1 base, and depending on what the base is, depends on how many triangles you have that are going to make up the different faces of your pyramid. So, all your prisms are made up of mostly rectangles. Now, they may have different bases, just like with our rectangular prism and our triangular prism. They have different bases, but the sides are made up of rectangles. These are pyramids, which have different bases, and their sides are made up of triangles. So pay attention to what the bases are and know that these are 3D shapes. You can take it and turn it and flip it, but pay attention to what the bases are.